Welcome to the deep dive. Today we're tackling a topic that can feel a bit daunting, maybe even like a high wire act if you're running Apache Cassandra clusters.
Yeah.
Upgrades.
Yeah, it's often seen that way.
Our sources actually call it an exciting challenge, which, sounds optimistic. Our goal here is to break it down so you see it that way. Too exciting, yes, but definitely manageable.
Absolutely. Keeping your Cassandra setup up to date is, well, it's just critical. And this deep dive is all about giving you the insights, the know-how to handle those upgrades with, hopefully, minimal disruption.
Minimal disruption. That's the dream.
Think of it as your guide, really, to keeping that Cassandra engine purring along smoothly.
Okay, and the information we're digging into today, it comes from a pretty comprehensive training course overview focused specifically on upgrading Apache Cassandra.
That's right, a solid source.
So consider this your express lane, if you will, to getting the essential strategies and the practical steps down. Right, let's kick things off. Why even go through the hassle of upgrading? What's the point?
That is the fundamental question, isn't it? Generally, software upgrades are just vital, period. They bring improvements, obviously, new features maybe, better performance often.
Bug fixes too, I assume.
Oh, definitely bug fixes. And crucially, updated security measures. That's huge. And this applies across the board, operating systems, applications, firmware. Yeah. And sometimes, getting the most out of these upgrades might even mean looking at new hardware or other resources.
Okay, that makes sense broadly.
Yeah.
But let's narrow it down to Apache Cassandra databases.
Yeah.
What's the main driver there? What's really critical when we talk Cassandra upgrades?
With Cassandra, it always comes back to availability.
Right.
You need to keep things running with, ideally, the absolute minimum downtime.
Near zero, I think I saw mentioned.
Exactly. Near zero downtime. And what's really cool is Cassandra's architecture, its distributed nature, actually allows for this. You can upgrade node by node. It's almost like working on a living system without stopping its heart. That's what makes near zero downtime actually achievable, unlike maybe some older database systems where an upgrade meant, well, lights out for a while.
That node-by-node approach sounds really key then. Now, before we jump into the how, the source mentions some prerequisites, things you should probably know beforehand.
Yeah, that's a good point. To really get the most out of this discussion, you kind of need a solid working knowledge of Cassandra itself.
Meaning?
Well, knowing what it is fundamentally, how to get it installed and configured, the basics, and also having some, basic admin knowledge under your belt.
Gotcha. So if you're maybe newer to Cassandra, or just need a refresher on those core ideas, getting that context first would be pretty helpful.
Definitely. It just makes understanding the upgrade nuances that much easier.
Okay. So, assuming we've got those basics covered, let's talk versions. The sources really stressed running supported versions. Why is that such a big deal in the Cassandra world?
Running supported versions in production is, well, it's highly recommended. It really boils down to stability, getting those security updates consistently, and having access to the latest features, and, importantly, those critical bug fixes.
Right. Security seems paramount.
Absolutely. If you stick with an unsupported or really old version, you're potentially leaving yourself open to known security holes or limitations that have, long been fixed in newer releases.
Makes sense. I also saw mention of current and archive versions. Where would someone find older Cassandra versions if they, for some reason, needed one?
Yes. The Apache Cassandra project maintains what they call an archived software web page. It's actually incredibly useful. You can download pretty much any past version of Cassandra from there.
Any version? Wow.
Yeah. This might be relevant if you, say, inherit an old system and need to understand its history, or maybe maintain compatibility with something older for a transition period.
That's a really valuable resource to know exists.
Okay.
Shifting gears slightly, Cassandra needs Java to run, correct?
That's right. The Java runtime environment, the JRE, is absolutely fundamental. Our sources highlight we'll be looking specifically at installing and configuring 3 different JRE versions.
3.
Version 8, version 11, and version 17. And we'll look at doing this on a Linux server.
Okay, 3 versions. Why the need to juggle multiple JREs like that?
Well, as Cassandra evolves through its major releases, the recommended and sometimes strictly required Java version changes along with it.
Oh, okay. So a Cassandra 3.x might need a different Java than a 5.x.
Exactly. So being able to install and, crucially, switch between these different JREs easily is vital for compatibility and just having a smooth upgrade path. This is where a Linux command update alternatives becomes really handy.
Update alternatives. Tell me more.
Think of it like your system's traffic controller for Java. You might have JRE 8, 11, and 17 all installed, but update alternatives lets you tell the system, okay, right now when a program asks for Java, point it to version 11 or version 17 or whatever you need for the Cassandra version you're running or upgrading to.
So it manages which one is active without uninstalling the others.
Precisely. It makes switching very straightforward.
Okay, so we've covered the Y upgrade, the background knowledge, versioning, and the Java dependency. Let's get into the meat of the upgrade process itself. The source mentions several key steps. Can you give us the bird's eye view?
Sure. Upgrading Cassandra isn't just, dropping in new files. It's a structured sequence of steps you need to perform, node by node, typically. And a really critical concept to get your head around here is something called S-stables.
S-stables. Okay, that sounds Cassandra specific. What are they?
Essentially, SS stables are the actual files on disk where Cassandra stores your data permanently. They're immutable, meaning they don't get changed once written. As data changes, new SS stables are created.
Right, immutable files.
And over time, especially across Cassandra versions, the internal format of these SS stables can change.
Okay, I think I see where this is going. So if the format changes in a new Cassandra version.
Exactly. That's where this command, node tool upgrade stables, becomes absolutely essential. You run this after you've installed the new Cassandra software on a node.
What does it do?
It tells Cassandra, hey, look at all the existing SS stables on this node and rewrite any that are in an older format into the new current format that this version understands. It's like translating old documents.
Translating documents. I like that analogy. And if you forget or decide to skip that node tool upgrade stable step, what are the consequences, the side effects the source mentioned?
Oh, you don't want to skip it. If you do, your newly upgraded Cassandra nodes might still be trying to read data from older format S tables. This can cause, well, first off, potentially significant performance problems.
Slower reads.
Yeah, potentially much slower. And it could also stop you from taking full advantage of new features or internal optimizations in the newer Cassandra version that rely on the updated SS table format. It's really a mandatory step for a clean upgrade.
Got it loud and clear. Node tool upgrade stables, don't skip it. Now,
It's really a mandatory step for a clean upgrade.
Got it loud and clear. Node tool upgrade stables, don't skip it. Now, the overview also differentiated between minor and major upgrades. What's the difference in the Cassandra context?
Okay, so a minor upgrade in Cassandra land is typically when you're updating within the same major release series. So going from, say, Cassandra 3.11.8 to 3.11.1 summon, that's a minor upgrade.
Just patching within the same major version.
Exactly. These usually focus on bug fixes, security patches, maybe some smaller improvements, but no big architectural shifts. Generally less risky.
Okay, makes sense. So a major upgrade is the bigger leap.
Precisely. A major upgrade means moving to a whole new major release number. Think going from Cassandra 3.x up to 4.x, or from 4.x up to the latest 5.x.
And those involve more changes.
Oh, yeah. Major releases often bring significant architectural changes, major new features, and because of that, they usually require more planning, more testing, just more care overall because more is changing under the hood.
That distinction is clear. Now, let's think big picture. What about those really large Cassandra setups? Clusters spanning multiple data centers. How do you even approach upgrading something that distributed?
Right. Upgrading large multi-DC clusters requires a very strategic phased approach. You definitely don't want to try and upgrade everything everywhere all at once.
That sounds like asking for trouble.
It really would be. Fortunately, Cassandra's architecture helps us out here again. A common and highly recommended strategy is to stagger the upgrades. Do one data center at a time.
So upgrade GC1 on Monday, check it, then maybe DC2 on Wednesday, something like that.
Exactly like that. Because each data center in Cassandra can operate somewhat independently within the larger cluster they replicate data, but they function on their own too. You can take one DC offline for the upgrade process, get it done, verify it, while the other DCs keep handling requests.
So the other data centers keep the application running.
Yes, assuming your application is configured correctly for multi-EC awareness, which it should be, this massively reduces the risk. If something unexpected happens during the upgrade in DC1, it's contained to DC1. It doesn't bring the entire global cluster down.
That staged rollout seems much, much safer for complex deployments. Okay, let's get practical. The course overview gave some specific upgrade examples. Let's walk through that first one.
Okay, example number 1. We're starting with a cluster running Cassandra version 3.11.8. The goal is to upgrade it to 3.1.1.130.
Which is a minor upgrade, as we discussed.
Correct. A minor in-place upgrade. And for this scenario, the cluster is running on Java OpenJDK 8.
Okay, so for this in-place minor upgrade, what are the key steps involved? What does the process look like on each node?
Typically, you'd start by downloading the software binaries for the target version, 3.1.16 in this case, and extracting them somewhere. Then, a really crucial step. You compare your current working configuration files, like cassandra.yaml, with the new default ones that come with 3.11.130
Why compare them?
to see what's changed, what new settings might be available, and most importantly, to make sure you merge your custom settings into the new configuration files correctly. You don't want to lose your specific tuning.
Right, got to carry over your customizations. Then what?
Then, you'd carefully stop the Cassandra service on the node, swap out the old binaries and configuration files for the new ones you just prepared, and restart the Cassandra service using the new version.
Okay, service restarted on the new version. Are we done with that node?
Not yet. Now comes that critical command we talked about. You run node tool upgrade stables on that node.
Ah, the SS stable translation.
Exactly. Let it run to completion. And finally, it's always good practice to actually verify the SS stable versions before and after running the command, just to be sure everything updated as expected. You repeat this whole process, node by node, through the cluster.
Download, compare, configure, stop, swap, start, upgrade SS stables, verify.
Got it.
Seems methodical. What about the second example? That was a major upgrade, right?
Yes, scenario 2 moves us into major upgrade territory. We start with a cluster on 3.1.17, and the target is version 4.1.7.
Big jump. From 3.x to 4.x.
It is. And importantly, this major upgrade also requires upgrading the underlying Java version on the servers. For Cassandra 4.x, you generally need to move to OpenJDK 11.
So 2 upgrades happening in sequence, really Java first, then Cassandra, or concurrently.
You'd typically handle the Java upgrade as part of the preparation before you start rolling out the Cassandra 4.x binaries. The core Cassandra upgrade steps download, configure, swap, upgrade stables, verify are similar, but there's that added complexity of the Java environment change and likely more significant configuration file adjustments between major versions. Needs more careful testing.
Okay, so major Cassandra upgrade often means major Java upgrade too.
Got it. And the third example, another major leap.
That's right. Example 3 takes us from Cassandra 4.1.7 up to the more recent version 5.0.2, another major upgrade.
And I bet there's a Java requirement change again. You bet. For Cassandra 5.x, the recommendation is to move to OpenJDK 17. So again, you have that Java upgrade component. Plus, moving to a major new version like 5.0 is often when you'd start planning to enable and test the brand new features that come with it to really leverage the upgrade.
So each major step up involves checking Java, potentially bigger config changes, and then exploring the new toys, the new features.
That's a good way to put it. It's a progressive path.
Okay. Now, the source also mentioned a completely different way to upgrade not in place, but moving to totally new nodes. When would that make sense?
Yeah, the migrate to a new cluster approach. This can be really useful in specific cases. For instance, maybe your existing servers are old, due for a hardware refresh anyway.
So combine the hardware and software upgrade.
Exactly. Or perhaps you have really strict change control on your existing production servers, and doing an in-place upgrade is just procedurally difficult or risky within your allowed maintenance windows.
You build parallel infrastructure.
Essentially, yes. You build out a completely new Cassandra cluster on new servers, running the target version and the right Java version. Then you work out a strategy to migrate the data from the old cluster over to the new one. Once migrated and verified, you switch your application traffic.
That sounds like potentially more upfront work, building the new cluster, but maybe less risky for the existing production system during the process.
It can be, yes. It offers a clean separation and allows extensive testing on the new cluster before it takes live traffic. It's a different trade-off.
Interesting alternative. Okay, wow, we've covered a lot of ground here. From why we upgrade, the prerequisites, versions, Java, those critical SS stables, minor versus major, handling big multi-DC setups, practical steps, and even this alternative migration method. What are the absolute key takeaways for listeners?
I think the main thing is that successful Cassandra upgrades really boil down to careful planning and understanding each step. Don't rush it. You should now have a much clearer picture, hopefully, of the best practices for different scenarios. Minor patches, major jumps.
Is everything.
It really is. Remember the key steps. Remember tools like node tool upgrade stables are not optional, and take the precautions needed. The goal is always a smooth upgrade with minimal risk and downtime.
So whether it's a small step or a giant leap in version numbers, understand the process, prepare properly, and execute carefully.
That's the core message. And armed with this knowledge, you should feel a lot more confident tackling whichever Cassandra upgrade comes your way.
Absolutely. And maybe one last thing for you to think about after this deep dive. When you do face that next upgrade, how do you make that strategic choice between upgrading your existing nodes in place versus building out a whole new cluster and migrating? What factors, beyond just the technical steps we discussed, think about your infrastructure, your team's comfort level, your